Assalamualaikum everyone. In today's episode, we focus on calculating for the instantaneous velocity and instantaneous acceleration using basic differential and integral calculus. So just sit back, relax, watch and learn. The problem is an object is moving along the x-axis at time equals 0. It is at x equals 0. Its x component of velocity Vx as a function of time is given by Vx as a function of time equals a times t minus b times the cube of the time t, where a equals 8.0 meter per second squared and b equals 4.0 meter per second to the fourth power. Question letter A, at what non-zero time t is the object again at x equals 0? Question letter B. At the time calculated in part A, what are the instantaneous velocity and instantaneous acceleration of the object? Give their magnitudes and directions. So for our solution, we first identify the given data. The object is moving along the x-axis, and at time t equals 0, it is located at x equals 0. Its x component of the velocity, denoted by Vx, as a function of time, is given by the velocity function Vx um, as a function of time t equals at, or a times t minus b times t to the cube, where a equals 8.0 meters per second squared and b equals 4.0 meter per second to the fourth. In part A, we are required to find a non-zero time t so that the object again is located at x equals 0. And in part B, using the time calculated in part A, we also find the instantaneous velocity and instantaneous acceleration of the object. Okay, both the magnitudes and the directions. And we also rewrite the x component of velocity, all right, or the velocity function, bx as a function of time equals 8.0 meter per second squared times the time t minus 4.0 meter per second to the fourth times the cube of the time t. We find the instant the object returns to x equals 0 by integrating the velocity function. This is to get the position function, right? The resulting position function is x as a function of time is equal to 1 half times a times t squared minus 1/4 times b times t to the fourth power. All right? We base it on the basic integration concept, like what is given here, right? The integral of x to the power n all right, dx is equal to 1 over quantity n plus 1 times x raised to the power n plus 1. We then solve for the time t, right? When this position x is set to 0. Well, 0 is equal to 1 half at squared minus 1/4 times b times t to the fourth, right? And then we first factor out t squared. So we get the equation 0 equals t squared times quantity 1 half a minus 1/4 times b times t squared, right? So we get 1 root, right? T squared equals 0, or simply t equals 0. And the other root is t equals 1 half a minus 1/4 times b times t squared, which is equated also to 0, right? Simplifying, we have 1 half times a equals 1/4 times b times t squared. But we consider only the value for the time t, which is a non-zero time, right? Equal to the square root of 2a over b. We now compute this time t using the given values for a and b. That is, the time t is equal to the square root of 2 times 8.0 meter per second squared divided by 4.0 meter per second to the fourth. Or, doing your math, we get the time t equals 2.0 seconds in two significant figures. So this is our answer to the question in part A. And for solving the instantaneous velocity at the instant time equals 2.0 second, all right, we just substitute the computed time t in part A into the velocity function, all right? That is, the instantaneous velocity v at the instant 2.0 seconds equals 8.0 meter per second squared multiplied by the time t minus 4.0 meter per second to the fourth multiplied by the cube of the time t. Substituting, we get 8.0 meter per second squared multiplied by 2.0 seconds minus 4.0 meter per second to the fourth multiplied by the cube of 2.0 seconds. So again, doing your math, all right, we finally get the instantaneous velocity of the object at time equals 2.0 seconds, which is equal to negative 16 meters per second, which means that the magnitude of this instantaneous velocity is equal to 16 meters per second in two significant figures, and that the object is moving towards the negative x-axis. Last but not the least, we solve for the acceleration at the same instant t equals 2.0 seconds. So we get the first derivative of the velocity function Vx over dt, right? The velocity function is a polynomial. So its derivative uh, requires a straightforward process, right? That is, the derivative of 8.0 meter per second squared times t is equal to 8.0 meter per second squared, right? And that of negative 4 meter per second to the fourth multiplied by t to the cube, right, uh, is equal to negative 4.0 meter per second to the fourth multiplied by 3 times t squared. All right. So with time t equals 2.0 seconds, we now get the instantaneous acceleration, all right, equal to 8.0 meter per second squared minus 4.0 meter per second to the fourth times 3 and multiplied by 4.0 second squared. So the result of which, when you do your math, is the instantaneous acceleration a sub x equals negative 40 point meter per second squared. All right, this is in two significant figures. So the direction of the acceleration is negative. That means the body is accelerating, all right, uh, towards the negative x-axis with a magnitude equal to 40 point meters per second squared. So this is our one of our answers to the questions in part B. So on these notes, let me say mabuhay till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.